A great day to one and all. I am Mr. Kim J.C. Ensho, a faculty member of Iloilo National High School SPSTE, and I will be discussing with you explicit and recursive forms of sequences. So what are these topics all about? Let's first have determining some terms of a sequence given its explicit form. To determine a particular term of a certain sequence, given the explicit form, just substitute a certain natural value to the function and evaluate. So if you are given this type, usually what you have to do is substitute a certain natural number, and all you have to do is simplify that expression until such time that you have the desired answer. For example, a certain sequence is defined by the function rule a sub n equals 5n plus 3. Find a sub 3. So note that for this one, if you could see, we have a sub n equals 5n plus 3. And since we are looking for a sub 3, you could see here that the subscript of a is 3. And hence, to look for the third term, all you have to do is substitute all n's with 3. So in this case, since we are looking for the third term, then let n equals 3. Thus, the third term is, by substitution, we have a sub 3 equals 5 times 3 plus 3. So basically, we just replace all n's with n equal with 3. And using your GEMDAS rule now, 5 times 3, it's 15 plus 3, and that gives you 18. Therefore, the third term of the sequence defined by a sub n equals 5n plus 3 is 18. I hope you understood it. Let us have another example. This time, I would like you to write the first 5 terms of the sequence determined by f of n equals n squared minus 1. Note that in our previous videos, the nth term of a sequence is denoted by a sub n or f of n, whichever is applicable. So for this one, since we will determine the first 5 terms, then we will let n be equal to 1, 2, 3, 4, and 5. Note that these are the first 5 natural numbers, and so we will be replacing n with these natural numbers and determine the first 5 terms. Let's have first the case. How about if I have n equals 1? So replacing all n's by 1, we have f of 1 equals 1 squared minus 1. Simplifying this will give you 1 minus 1 or 0. This means that 0 is the first term of this sequence. If n equals 2, replacing all n's by 2, you have f of 2 equals 2 squared minus 1 here. 2 squared is 4. We have minus 1. It's equal to 3. Hence, the second term of this sequence is 3. If n is equal to 3, we have f of 3 equals 3 squared minus 1 equals 3 squared. We know it's 3 times 3 or 9 minus 1. That gives you 8. So 8 is a third term of this sequence. If n equals 4, replacing n's by 4, we have f of 4 equals 4 squared minus 1, which is equal to 16 minus 1 or 15. And for the fifth term, Replacing n by 5, we have f of 5 equals 5 squared minus 1, which is 25 minus 1 or 24. Hence, these are your first 5 terms. If you wish, you could also denote this by a sub 1 equals 0, a sub 2 equals 3, a sub 3 equals 8, a sub 4 equals 15, and a sub 5 equals 24. They mean one and the same thing. And here are your 5 terms. Thus, the first 5 terms of f of n equals n squared minus 1 are 0, 3, 8, 15, and 24, respectively. I hope you got the correct answer too. So now let's have these exercises. Let's have this one. Given the function, determine the indicated term. In this particular part, you may solve as well. You may pause the video from time to time and check if you have the same answer as I did. Let's have a sub n equals 1 minus 4n, and you're looking for a sub 20. So here we have a sub 20. So we are looking for the 20th term. So we will replace n, all n's here by 20. So with that, we have a sub 20 equals 1 minus 4 times 20. 4 times 20, it's 80. So we have a sub 20 equals 1 minus 80. And that gives you a sub 20 equals negative 79. Hence, the 20th term of the sequence is negative 79. Let's have another one. F of n equals 3 times the square of n minus 2. And we're looking for f of 4. So we will substitute our n with 4. With that, we have f of 4 equals 3 times the quantity 4 minus 2 squared. 4 minus 2 is 2. And we have 3 times 2 squared. 2 squared is 4. So we have f of 4 equals 3 times 4, which simplifies to 12. Hence, the fourth term of this sequence is 12. Letter C. If a sub n is equal to 2 raised to n plus n squared, what is the value of a sub 3? So since our subscript here is 3, so we will replace all n's here with 3. So we have a sub 3 equals 2 cubed plus 3 squared. 2 cubed means 2 times 2 times 2 or 8. 3 squared means 3 times 3 or 9. So a sub 3 is equal to the sum of 8 and 9, which is 17. I hope you all got these 3 exercises. And if you did, congratulations. But if not, you can still work on it. All right. Let's have the next one. Determine the first 3 terms of a sub n equals the product of n plus 1 and n minus 3. So since we will determine the first 3 terms, so we will find the value of this expression when n is equal to 1, 2, and 3. Let's have first n equals 1. If n is 1, replacing all n's by 1, you have a sub 1 equals 1 plus 1 times the quantity 1 minus 3. 1 plus 1 is 2. 1 minus 3 is negative 2. And 2 times negative 2 is negative 4, which is your first term. For the second term, let n be equal to 2. Replacing all n's here by 2, we will get a sub 2 is equal to 2 plus 1 times the quantity 2 minus 3. 2 plus 1 is 3. 2 minus 3 is negative 1. And 3 times negative 1 is negative 3. Negative 3 here is your second term. For the third term, let n be equal to 3. So by substitution, we have a sub 3. It's equal to the sum of 3 and 1 multiplied by the difference of 3 and 3. This becomes 4 times 0 or 0. So 0 is your third term. And if you have questions or clarifications, feel free to reach me at my contacts. Or you can also pause the video from time to time for clarification. And you may replay it as you wish as well. So here are your first three terms. Negative 4, negative 3, and 0. Next number, or let's have the next one. How about determining some terms of a sequence given its recursive form? When we speak about recursive form, you're actually utilizing some portions of or some terms as basis to determine the value of other terms. A certain sequence is in recursive form if a sub 1 and a recursive formula are given. So if you are given the first term or a certain term and a certain recursive formula that utilizes other terms, then you have a recursive form. A recursive formula is an expression used to determine the end term of a sequence by using the term that precedes it, or in some cases, after it, depending on the situation. Let's have an example. Use the recursive formula a sub n is equal to a sub n minus 1 plus 2, given that a sub 1 is equal to 13, to determine the values of the second, the third, and the fourth terms. Remember, if your term is a sub n minus 1 is the term that immediately precedes it or is immediately before it. So in a similar way, if you're looking for a sub 2, we will be replacing all n's by 2. So here, in this recursive formula, I change all the n's by 2. So I have a sub 2 equals a sub 2 minus 1, or you have a sub 1 plus 2. That's why you have it here. And if you could see, the value of a sub 2 depends on the value of a sub 1. But you could see here from the given that a sub 1 is 13. So to get the value of a sub 2, we will substitute a sub 1 by 13. And you have 13 plus 2 equals 15. Hence, a sub 2 is 15. Now let's have a sub 3. To determine a sub 3, your subscript here is 3. So in this case, in this recursive formula, we will replace all n's by 3. So you have a sub 3 is equal to a sub 3 minus 1 or 2. So you have your a sub 2 plus 2. Take note that you have to follow the structure. And you might ask, so in this case, you need a sub 2. Where do we get this? Take a look at here. A sub 2 here has a value of 15. So in that case, to get a sub 3, you will substitute a sub 2 with 15 plus 2, and that gives you 17. And for a sub 4, we will replace all n's here with the subscript, which is 4. And in this case, so you have a sub 4 is equal to a sub 4 minus 1 or a sub 3 plus 2. But we know that a sub 3 is 17. So by substitution, you have 17 plus 2, which is 19. Hence, the fourth term of this sequence is 19. I hope that you understood this well. Let's have another one. Use the recursive formula a sub n is equal to 3 times the quantity a sub n minus 1 minus n, given that a sub 1 is 2, to determine the second, third, fourth terms. So using a similar manner, so we're looking for a sub 2, so we will substitute all n's or replace all n's by 2. So with that, you have a sub 2 equals 3 times a sub 2 minus 1 or a sub 1 minus 2. Remember, all n's have to be replaced by 2. So we have it here. A sub 2 is equal to thrice of a sub 1 minus 2. But what is a sub 1? It is 2. So by substitution, it's 3 times 2 minus 2, which is 6 minus 2 or 4. Hence, the second term is 4. How about the third term? We will replace all n's by 3. So you have a sub 3 equals 3 times a sub 3 minus 1 or a sub 2 minus 3. That's why you have this equation here. But what is a sub 2? A sub 2 is 4. So by substitution, a sub 3 is equal to 3 times 4 minus 3, which is 12 minus 3 or 9. So 9 is our third term. And for the fourth term, of course, we will replace all n's by 4. So you have a sub 4 equals 3 times a sub 4 minus 1 or 3 minus 4. That's why you have this formula here. But remember that a sub 3 is equal to 9. So you have 3 times 9, which is 27 minus 4. That gives you 23. Hence, the second, third, and fourth terms are 4, 9, and 23 respectively. I hope you got it. All right, let's have this exercise. Given f of n equals twice of f of n minus 1 plus 1, with f of 1 equals 3, determine f of 3. But you have f of 1. To determine f of 3, you still need the value of f of 2, right? So we need to look for the value of f of 2 first. So we represent or replace n with 2 for a while. So with that, replacing all n's by 2, we have f of 2 equals 2 times f of 2 minus 1 or f of 1. We have f of 1 plus 1. But what is f of 1? Based on the given, it is 3. Therefore, substitution gives us 2 times 3 plus 1, which is 7. So 7 is the second term. However, it is not yet the final answer because we are looking for f of 3. So if we have f of 3, we will replace all n's here by 3. So you have f of 3 equals twice of f of 2 plus 1. But we know that f of 2 is 7. So replacing f of 2 by 7 gives us 2 times 7 plus 1, which is 14 plus 1 or 15. So 15 is the third term of this sequence. Let's have another one. Given the formula a sub n equals twice of a sub n minus 1 plus a sub n minus 2, with a sub 1 equals 3 and a sub 2 equals 5, find a sub 4. We have a sub 1, we have a sub 2. To look for a sub 4, I believe it is necessary that we have first the value of a sub 3. So if we're looking for a sub 3, we will be replacing all n's by 3. So we have a sub 3 equals 2 times a sub 3 minus 1, that's 2. That's why you have here 2a sub 2 plus a sub 3 minus 2, that's 1. You have a sub 1. So the third term is twice of a sub 2 plus a sub 1. But we know that a sub 2 is 5 and that a sub 1 is 3. So substitution gives us a sub 3 equals 2 times 5 plus 3, which is 10 plus 3 or 13. Now that we have the third term, we can now have the fourth term. So we will replace n by 4. So we have a sub 4 is equal to twice of a sub 4 minus 1 or a sub 3 plus a sub 4 minus 2 or a sub 2. So from here, a sub 3 is 13 and a sub 2 is 5. So by substitution, we have a sub 4 equals 2 times 13 plus 5. 2 times 13 is 26 plus 5. This gives us 31 as the fourth term. Let's have another one. This time you are given a term with a higher subscript. We have to look for a term with a lower subscript. Given the recursive formula a sub n equals a sub n minus 1 plus 3, with a sub 3 equals 15, find a sub 1. So we have to look to work somehow backwards. Given a sub 3, to get a sub 1, we still need to get the value of a sub 2. So we will let n be equal to 2. For this case, rather, let's have n equals 3. Let's have n equals 3, and you will see the reason why. If n is 3 here, because of the subscript, by substitution here, it becomes a sub 3 equals a sub 2 plus 3. And from here, a sub 3 is 15. And we can now get the value of a sub 2 by subtracting both sides by 3. So this gives us the value of a sub 2, which is 15 minus 3 or 12. This time, after having 3, we will now have the lower subscript 2. So we will replace all the n's here by 2. With that, you will have a sub 2 equals a sub 1 plus 3. But what is a sub 2? It is 12. So by substitution, you have 12 equals a sub 1 plus 3, and subtracting both sides by 3, that gives you the value of a sub 1 or the first term as 9. Thus, the first term is equal to 9. All right. I hope you got it. Let's have another exercise. Given the recursive formula a sub n equals a sub n minus 1 minus n, with the third term equal to 10, find the first term or a sub 1. So using the similar manner, we will let n be equal to 3 because that's the given. So with that, we have a sub 3 equals a sub 3 minus 1 or a sub 2 minus 3, because remember all n's have to be replaced by 3. And we know that the third term is 10. So a sub 3 here will be replaced by 10. So you have 10 equals a sub 2 minus 3. You add 3 both sides. That gives you 13 as the value of a sub 2 or the second term. Now that you have a sub 2, the subscript here is 2. So we will replace n with 2 this time. So replacing all n's here by 2, we have a sub 2 equals a sub 1 minus 2. And from here, adding both sides by 2, but before that, we know that a sub 2 is 13. So by substitution, you have 13 equals a sub 1 minus 2. Add 2 both sides, and you will get 15 as the value of the first term. Thus, the first term is 15. And if there are questions or clarifications, again, please feel free to reach me. Or if you wish, you may also pause the video from time to time. You may go back to it so that you may understand it better. With that, thank you very much and a great day to one and all. God bless everyone and take care.